So we're talking about 2.6. This is technically the last set of notes for chapter 2. We do have some classwork days that ahead of us, but these are for our chapter 2. When we come back from break, we will be doing our. It's technically in place of our chapter test. We're going to be doing a chapter project. So we'll be focusing on that when we get back from our Thanksgiving break. And some of your classmates vehemently said they don't want a project over break. So fine, I guess I won't give you guys a project. I'm kidding. I wasn't going to give you a project anyway because that's me. All right, let's go ahead and get started here. So 2.6, we talked about exponential functions in 2.4, 2.5, okay? And 2.6 is about quadratic models now. So another model that's very, very commonly used in the real world, especially when we talk about motion and projectile motion, we use quadratic models, okay? So our objective for the day, rigorous thinkers and learners will be able to identify and calculate key parts of quadratic functions and model data with them by completing problems as taught, okay? So there's a lot of different places that you can see quadratic functions being used in the real world. As I mentioned, one of the main things is like projectile motion. So launching things into the air and then looking at their motion as they're like going up and coming down. Other places that you can see quadratic models a lot is architecture, okay, especially civil engineering with bridges and the bridge lines and all that stuff. So this looks like the Golden Gate Bridge, but if you look at, have you been over the new Long Beach Bridge? I forget the name of it. It's like Gerald something. But they also used the quadratic models for these suspensions, right? So it's used to figure out the length of this cable and then the height of the cables that attach to them, right? So quadratic models are used on a lot of places. We just don't explicitly notice them. We're going to be looking at the standard form of the quadratic function today. And we're going to review a little bit about, and I say review because we spent a good like 2-3 chapters on quadratic functions last year in Algebra 2. So technically this is a bit of a review. But we're really going to focus on that standard form of the quadratic function. And if you guys remember standard form of the quadratic function, f of x is equal to ax squared plus bx plus c. A, b, and c are coefficients. Okay, and for this model, we definitely cannot have a equals 0. That's a big no-no. Now, every quadratic model, an important part of the quadratic function or model is the vertex of your function, okay? The vertex of our function gives us a lot of information. It gives us the highest point of an object or the lowest point or lowest height of a bridge maybe. But it gives us that highest or that lowest, right, for the vertex. And so we need to be able to find our vertex from our quadratic function. We need to be able to find it from standard form. If you guys remember, we had 2 other forms of the quadratic function. We had a vertex form here. And vertex form was nice because it was easy to identify our vertex directly from here. So we had our f of x is equal to a times x minus h squared plus k, right? Where our vertex here is just simply h and k. So that was our vertex form. And then our then we had intercept form. If you guys remember intercept form. Okay, intercept form, we had f of x is equal to a times x minus, I forget the letter, the R1, right, for roots, and then x minus R2, just like that. And to find our vertex, we had to do an average of our roots here because our vertex ends up falling right in the middle of them. And so to get our x, we would do R1 plus R2 divided by 2. And then whatever that was, right, it would essentially be whatever our f of h is here. Okay. But that's just vertex and intercept form. Standard form is very much like intercept form, where we have a nice little formula to find the x, and then once we find the x or the h, we can plug it into the function to get our y for our vertex, or the k, right? So our x comes from our axis of symmetry in standard form. Here, I'll move this over just in case anyone is still writing that. But if you remember our axis of symmetry in standard form, our axis of symmetry is that line that creates the mirror image of the graph, right? So our axis of symmetry goes right down the middle of our parabola, or our quadratic function, and it essentially goes right down the middle, and it creates a mirror image of our parabola. So if I were to take this side and fold it over my axis of symmetry, they would fall directly on top of each other. Same thing here, right? So our axis of symmetry actually goes right through our vertex. And so it's this vertical line that's going through our vertex. And so in order to find our axis of symmetry, we can just use x is equal to negative b, where the b comes from here, divided by 2 times a, where the a is coming from your function as well. That's going to give you your x of your vertex. Okay, so that's why for our vertex, we have this negative b over 2a here for the x. And then once we figure out what our x is here, we can just take our x and plug it back into our function right here, and we can get our y. So that's why our y here is f of x, right? So we can say that h is found by doing negative b over 2a, and k is found by doing f of our x, or f of h, right? That would essentially be the gist of it. I'm hoping that most of this is ringing a bell to you guys. Okay, for our axis of symmetry here. And remember that our axis of symmetry is always written in an equation of a line. So we never just write the number. It's never just a number for our axis of symmetry. It has to be x equals our axis of symmetry, because it's a line, it's a vertical line. And so when we write x equals, we're writing the equation for this vertical line. Okay. So our vertex is our maximum or our minimum point. Okay. And we just have to make sure we realize when it's a maximum and when it's a minimum. Okay. So usually if our parabola is opening downward, that means our vertex is going to be a maximum. If our parabola is opening upward, that means our vertex is a minimum. Okay. And of course, we can tell if our parabola is opening up or down based on our A. So if A is positive, then our parabola opens down. I'm sorry, it opens up, and our vertex is a minimum. If our A is negative, then our parabola opens down, and our vertex is a maximum. Okay. Let's do a quick check real quick. So far, if we're doing okay with this information, give me a thumbs up in the participants window. We're doing good with this information. Give me a thumbs up in the participants window. If you have questions or you're unsure about something, you can give me a thumbs down. Okay. So sorry. All right. That's great, guys. Okay, so let's take a look. Let's do some examples here. Okay. We're given a few parabolas here, and we're asked to determine the vertex, whether the vertex is a maximum or a minimum, and the axis of symmetry. All right. So we're not given a function, we're instead given a graph. That makes life a little bit easier because we don't have to do a lot of calculations. But just looking at this parabola, we can see it's opening upward. Our vertex is right here, it looks like, right? Yep. Which means that our vertex is going to be a minimum. Okay. And then our vertex is right on the x-axis here, so that means our y is going to be a 0 because it's on the x-axis, and then I can just calculate here -1, -2. So my vertex is at -2, 0, which means my axis of symmetry, I look at the x coordinate, right, for my axis of symmetry. So then my axis of symmetry is going to be x is equal to -2. It's a line that goes right through x equals -2 there. Okay. Any part of that, I know I went fast there, but any part of that, do we have any questions on any part of that? How I determined if it was a minimum, how I determined the vertex or the axis of symmetry? You can type it in the chat, or even faster, you can unmute and speak. Okay, let's have you guys do the second example here then. Okay, I'll give you guys about a minute to do that. Give you a minute to do that second example. When you're done with the example, in the chat, I want you to privately message me your answers. So give me the vertex, whether it's a max or min, and the axis of symmetry in the chat privately, please. Okay, thank you to Nick, Ariana, V2, and Juan for your responses. Still waiting on the rest of you. Thank you, Wally. Anthony, I want all three answers, please. Thank you, William. Thank you, Aaron. Thank you, Anthony. Thank you, Lumeria. Still waiting to hear. There we go. Thank you, Kelly. Still waiting to hear from Kai. And I believe, oh, there's Zon. Okay, so there was a little bit of difference in the vertices that you guys were giving me, or vertex. Some of you said 415, some of you said 416. I can understand why that might happen. If I take my straight edge here, that does look a bit like 416. So 10, 11, 12, 13, 14, 15, 16. Yeah, so that does look like 416. But I'm not going to ding you for that. Okay. So our vertex is 416. It is a maximum, as many of you said, actually, as all of you said. I shouldn't say many, all of you. And our axis of symmetry is x equals 4 right through that guy right there. Okay. So well done to all of you that participated. I think there's only one of us that did not participate. Okay. All right, let's flip it over. Okay. So let's talk about our roots. So in the real world, okay, the roots of a quadratic function are actually quite important. Okay. They can tell you what in a projectile motion problem, they can tell you when the object will be on the ground, or when it leaves the ground, and when will it be back on the ground. So it's important for us to be able to find the roots in a bridge type situation. Your parabola will most likely not have roots, just because it's not going to be on the ground, right? Your vertex is a minimum. But when your parabola is a maximum and you launch something in the air, you want to know when it's going to come back down and where it's going to come back down. So that's really important as far as our x-intercepts here and our roots. So we want to make sure we are able to find our x-intercepts and our y-intercepts. Okay, so our x-intercepts are the points where the value of f of x equals 0. So our y equals 0 here. Okay, y equals 0 there. Where the graph crosses the x-axis. And we're not going to focus on any other type of solving, because I know we spent an entire chapter on solving quadratics last year. We're just going to focus on our quadratic formula here. Okay. That's going to be our focus. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. If you guys remember the song, you can sing the song. If you remember the pessimistic b, you can recite that story for yourselves. So we're going to focus on just using the quadratic formula. We're not really going to go into like factoring and completing the square and all that wonderful jazz. Okay. We also do have a y-intercept, and our y-intercept can be found from our standard form. okay, is the point where the value f of 0 equals c. So for our y-intercept, actually, okay, from our standard form, c is our y-intercept. So the point of 0 comma c is our y-intercept from standard form. Okay, 0 comma c. And we get that when, of course, when our x is 0, right? Okay. So when we're dealing with modeling, right, when we're dealing with modeling quadratics, we do want to know the different types of roots in general, right? So when our parabola is crossing our x-axis in two places, okay, that gives us two distinct real roots. So distinct meaning different, right? So we have two distinct real roots. So that would be these two intersections with the x-axis. And then if our parabola has its vertex directly on the x-axis, that's like the only time it touches the x-axis, then we have two equal real roots, meaning we have two of the same exact number as a root. This is when we would get like those identical factors, if we would factor like x plus 3 times x plus 3, or x minus 2 times x minus 2, where your root is essentially going to be the same number when you separate and solve them. And then you have your complex roots. If you remember our eyes, right? And that's when our parabola doesn't touch our x-axis at all. So it's either opening upward and completely above the x-axis, so it's never going to actually come downward and touch it, or it could be below the x-axis and opening downward, right? And that way it's never going to actually touch it either. So we have the two real roots, two distinct real roots, right, which we call two real roots, two equal real roots, which we would say was like one root, and then 0 real roots, or two complex roots. Okay. All right, let's take a look here. That says find the x and y intercept of the given equation here. Okay. So before we can solve any equation, we must have one side equal 0. If one side, oops, I can't see that. If one side doesn't equal 0, then whatever we do is going to be incorrect. So by making this one side equal 0, you're essentially saying that your function is going to equal 0. This is the equivalent of saying y equals 0. You're saying your function is equal to 0, aka f of x equals 0, right? What we were seeing right up here. F of x equals 0. That's what we're saying here. So that's why we have to make our function equal 0 so that we can get that f of x equals 0 situation happening there. All right. So to find our x-intercept, we use our quadratic function or quadratic formula. I apologize. We have our a, we have our b, and we have our c. Oh, okay. So our a is equal to positive 10. Our b is equal to a negative 6. Okay, that sign does come with it. And our c is equal to a positive 1. So now we take our quadratic formula and we plug things in. Okay, so we will have x is equal to, with parentheses here. Okay, I have a negative b. Okay, so this negative comes from the actual formula, and then I have my negative 6 as my b. Okay, and then I have plus or minus the square root of b squared. So b squared here is going to be negative 6 squared, okay, minus 4 times a times c. So my a is going to be 10, my c is 1. Okay, let me move that up. I was holding it low so you guys can see the formula, but it is on your paper as well. All over 2 times my a, which is 10. Okay, And now I have to go through and I have to simplify. Okay, we work on the inside first before we can simplify these guys as far as like multiplying, but we can't really add or subtract them until I've dealt with my radical there. So negative 6 becomes a positive 6 there, plus or minus the square root. Now, negative 6 squared is going to be a positive 36 minus 4 times 10 is 40 times 1 is 40. So negative 4 times 10 times 1 is a negative 40. So I have negative 40 there. Okay. All over 20. And then I continue simplifying. So 6 plus or minus 36 minus 40 is going to be a negative 4. Can't take the square root of a negative number, right? So this is going to tell me that I have two complex roots because I'm going to now have to bring in I here. You guys remember I? Right? So the square root of negative 4, right? That splits into the square root of 4 times the square root of negative 1. The square root of negative 1 is I. And the square root of 4 is 2. So this becomes 2I. So this right here, I get 6 plus or minus 2I over 20. And then I can simplify everything by a 2, right? I can simplify everything by 2, so I can pull out a 2 from here. This will be 3 plus I, or plus or minus I, sorry, over 2 times 10 here. These will cancel. So my roots are 3 plus or minus I over 10. And that's pretty much all I can leave it as. I can't really take it any further than that. So this is two complex roots. Okay. And then my y-intercept is actually, before I talk about the y-intercept, do we have any questions there? Any needs for clarification on any part of that? I want to give you guys enough time in case someone is writing in the chat. If you happen to have a question or something pops into your head, please don't hesitate to ask, okay? Okay, so our y-intercept is actually much easier. We simply just look at the c of my function. Here is my c. So my y-intercept is literally just going to be 0, 1. That's it. That's all there is to it. Okay. That's all there is to it. If we take a look at our next example, we have x squared plus 4x plus 8 is equal to 8x plus 29. Notice how it's not equal to 0. It's equal to 8x plus 29. So we do have to make some changes there and make it equal 0. So the first thing we got to do is we got to subtract over that 8x and that 29 there. So we'll have, I'm going to recopy that. So we're going to subtract over the 8x here, and we'll subtract over the 29 there. So these guys will now become 0. And over here, I'll have x squared. 4x minus 8x will give me that negative 4x. And then 8 minus 29 is going to give me negative 21 there. Okay. And then we go ahead and we do our quadratic formula here. Okay. So once again, our a here, we don't have a number in front of x squared, or do we? Right, that's our ninja 1 right there. So our a is 1. Our B is going to be -4, and our C is going to be a -21. Yay. All right. So if we take a look at all of that, we have x is equal to negative, okay, from the formula, and then I have a -4 there for my b, plus or minus the square root of my b squared, which is going to be -4 squared, minus 4 times my a times my c. Okay, so my a is 1, and my c is -21. All over 2 times my a, which is 1. Okay. So now we go through and we start simplifying. Okay. -4, change that to a +4, plus or minus the square root. -4 squared is 16. Over here I have -4 times 1 times -21. Okay. So negative times negative is going to make this positive. So this is going to change to a plus. So 4 times 1 times 21, that's going to give me 84. Okay, all over 2. Keep simplifying here. I have 4 plus or minus, well, 16 plus 84 is 100. So I have the square root of 100 there, all over 2. So when I take the square root of 100, that's actually a real number, right? I can take the square root. So I have 4 plus or minus 10 divided by 2. Okay, but I don't leave it like that because that's not, there's no I there. I can actually split this and I can do my 2 equations here. So I'm going to split this. Okay, I'm going to split this and I have x is equal to 4 plus 10 over 2. Okay, or x is equal to 4 minus 10 over 2. So you're splitting the plus or minus there, right? So this is going to equal 14 divided by 2, which is 7. And then this is going to equal -6 divided by 2, which is -3. So I have my x equals 7 and -3 there. Okay. Which means my x-intercept, right? My x-intercepts here, I can write them right over here. Running out of space. I hope you guys are using your space more wisely. My x-intercept, so for x-intercept, your y's are 0, right? So I have 7, 0, and I have -3, 0. Those are my x-intercepts there. Okay. And then for your y-intercept, you have to be careful. Don't go back to here. You want to use the form that has f of x equals 0, where your one side is equal to 0. So we're using this form here. Oops, sorry. Okay. So your y-intercept here is going to be 0, -20. Right? Okay. Let me get a response from you guys, how we're doing so far. Give me a thumbs up if you are good with both of these examples. No questions. Thumbs down if you have a question. Thumbs down if you're unsure, have a question, or anything of that nature. Let me get that response from you guys. Also to know if you guys are awake, listening, paying attention, enjoying my soothing voice. Okay, let's see here.
Miss K, could I see y-intercept for example 1?
Yeah.
Thank you.
You're welcome. All right. So let's take a look now. All right, let's flip it over. We don't have much more, but so the next few examples are actually pulling back to it's the same exact function, right? We have the same two functions as the previous page, but now we're using information, or we're going to use methods from the first page of notes. So we want to find the vertex and determine if it's a maximum or a minimum. Okay. So remember, we're in standard form here, right? So our vertex is going to be found by doing x equals negative b over 2a, right? So our vertex is going to be negative b over 2a, whatever we get there, and then plugging that into our function there. And then, of course, our max and our min can be determined by a, right? So same two functions as what we just found the roots for, but now we're finding the vertex and determining if it's a maximum or a minimum. So over here, let's see. We can see if it's a maximum or minimum by looking at our A automatically. Okay, over here we have 10 for our A, and it's positive, right? So A is positive, which means our vertex is a minimum. A is positive, which means our vertex is a minimum. Okay, so now we move on to finding our h and our k, or our x and our y, depending on however you want to look at it for the vertex. So to find our x, we're going to do x is equal to negative b over 2a. So once again, we're going to need our b, right, and our a. Okay, so over here, again, the negative is from the formula, and then I have my b. So that's going to be a negative 6. So negative 6 divided by 2 times my a, which is 10. Okay, so that's going to be 6 over 20. And I can simplify that. 6 over 20 can become 3 over 10. If I wanted, or I can get that as a decimal. But that's going to be a irrational decimal, because it's going to continue on and on and on. Or if you have an ending decimal, like just 0.3, you can definitely change that to just x equals 0.3. My bad. I was thinking about the 0.33333333333. If you were to divide, never mind. Having issues this morning. So our x is equal to 0.3 or 3 over 10. It's depending on how you want to leave it and work with it. So for our vertex thus far, I'm going to start it off right here. Okay. Our vertex so far, okay, we can put it as a 0.3 for our x. That decimal is so far away from that 3 that it's like, what are you doing? There we go. So now to get the y, we're just going to take that guy and we're going to plug it into our function here. Okay. So we'll do f of 0.3 is equal to 10 times 0.3 squared minus 6 times 0.3 plus 1. Okay. And honestly, you don't need to like go through all the different types, all the tiny little steps of finding out your vertex and blah, blah, blah. If you want to literally just put in this exact thing into your function, just like that, and calculate it, you absolutely can. There's nothing stopping you from doing that. So, or if you want to see each part work out, then you can absolutely just do each little part. So this would become 10 times 0.09 minus 6 times 0.3 plus 1. So times, oops, times that by 10. You get 0.9 there. You get negative 6 times 0.3. You're going to get a negative 1.8 there plus 1. And then 0.9 minus 1.8 plus 1. And you're still going to get the same answer, like 0.1. So f of 0.3 is equal to 0.1, which means that's going to equal 0.1. So our vertex here is 0.3 comma 0.1, and it is a minimum. Okay. For the second example, same thing applies, guys. It has to equal 0. We can't start it unless it equals 0. So we still gotta we gotta move these over. Minus 8x minus 29 minus 8x minus 29, right? So we get x squared minus 4x minus 21 equals 0. That's what you're using for your a and your b. That's the function you should also be using here. Although in the case of finding, like plugging it in to find your y, you could use that guy too, but it's best to use the function that you make equal 0, okay? Because that's your actual real function. So we can go ahead and do you guys want to try this one on your own? Here, I'll give you guys 5 minutes, okay? 5 minutes to find your vertex and tell me if it's a maximum or a minimum. Okay, so when you're done, private message me your answer of your vertex and max or min. I'll give you guys 5 minutes to work on that. When you give me your answer, hopefully it takes less than 5 minutes, but if it doesn't, then it is what it is. This is very interesting. Aaron, we're trying to find the vertex, hun. Vertex. We already found the x-intercept. Okay. So it looks like everyone got the same x, but there's variation in the y's. I'm seeing like negative 25. I'm seeing not negative 9. I'm seeing negative 7. So let's see what's going on here with our work. So for my x, I have negative 4 over 2 times my a, which is 1. So that's going to be a positive 4 over 2, which is 2, right? So yes, my x is equal to 2. Now, if I plug this in, I'm doing f of 2. So that's going to be 2 squared. I'm using this one here, minus 4 times 2 minus 21. Okay, so this is going to be 4 minus 8 minus 21. That's going to be a negative 4 minus 21, which is a negative 25. Okay, please double check your work to see if something went wrong there. Okay. So that means our vertex, it should be 2 comma negative 25. And for maximum or minimum, look at your A. Your A is positive, which means this is a minimum. Okay, let's take a look at quadratics in the real world. Yep. Shall we? Hopefully you're able to, those of you that had like that -9 and that -7, hopefully you're able to find your mistake here and correct it. Okay. So let's take a look at our information here. It says find a quadratic function to model the values. Juvenile violent crime arrests. Okay. In the years of 1988, we had 327 violent crimes. 1990, we went up to 424. Okay. 1992, we had 488. 1994, we had 527. 1996, so we had 460. 1998, we had 370. Okay. So if we continue reading, though, it says, let's call 1988 the start of the data at t equals 0. So we're saying that 1988, our t equals 0, aka our x would equal 0. Okay, so our time, our year would equal 0 at 1988. Okay, which means at 1990, right, that's 2 years after. So that's going to be added 2. So 1994 would be 4 years. 1992 would be 4 years. 94 would be 6 years from 88. 96 would be 8 years from 88. 98 would be 10 years from 88. They're using this information, which translates to an XY table here, right? Where at 424, I have a 2 for my X. At 527, I have a 6 for my X. And at 370, I had a 10 for my X. Okay. So we can kind of already see this is kind of like, we can see that it follows a little bit of a quadratic pattern here because it's a low and then it gets high and then it starts getting low again. Okay. So what we need to do, okay, is in order to figure out a model, a function, okay, for this real world problem, okay, we're trying to find a quadratic function model, right? In order to find a function, we simply just need 3 points. So all we need is 3 points and we can actually try to do like a system of equations to solve for the rest of them, okay? So we're going to spread them out for an accurate reading here. So I'm going to use these 3 points here. I'll use that one in blue, that one in pink, and that one in purple. And I'm going to take each one of these points and I'm going to plug it into what I know here, okay? So I know that this point here is 2, 424. So my x is 2, my y is 424. So my y is my f of x. So that's going to be 424 here is equal to, I don't know my a, b, or c, right? So my a is going to be, I'm going to leave that as a. But my x is 2. So this is going to be 2 squared. Okay. I don't know my b, but I know my x is 2. And I don't know my c. Okay. So if I simplify this, I'll get 424 is equal to 4a plus 2b plus C. Let me move that up, sorry. Okay, so that's my first equation. Now the second equation is based on my second point, 6 and 527. Okay, I could have used any of these points, any three of them. These are the three that I chose to go with here. Okay, because they're nicely spread out. They're like 4 things apart each. So for this one, it's 6 comma 527. Okay, so my y is 527. That's going to go in for the all of f of x, right? Because f of x is y. So I have 527 here. Again, I don't know my a, but I know my b is 6, so that's going to be 6 squared. Okay, plus my b I don't know, times 6, plus my c. Simplify that. 527 is equal to 6 squared is 36, so that's 36a plus 6b plus c. So that's my second equation there. Okay, and then my third equation, I'm using again my 10 and 370 now. So again, 370 goes in for my f of x, so that's 370 there, is equal to my a times 10 squared now, plus b times 10 plus c. Okay, simplify that. I get 370 is equal to 100a plus 10b plus c. Okay. So what did I do? I took 3 points from the different data points and I plugged them in for x and y in my standard form. And notice I now have 3 linear equations, right? Because there's no squares here. I did all the squares. So all I'm missing is a, b, and c. Okay, so now we're gonna do elimination. You guys remember we had 3 variable linear system of equations, and we did this like at the beginning of algebra 2. So we're gonna do that now with this to figure out our a, our b, and our c. It's a process, I'm not gonna lie. It's most definitely a process. So I'm gonna go ahead and I'm gonna rewrite my 3 equations here on the back page, because that's where we're working with them. Okay, so I have 424. I'm gonna flip this. I'm gonna move this y over to this side. So 4a plus 2b plus c. And let me move this down here. Okay, so I'm gonna write it right here. 4a plus 2b plus c is equal to 424. Okay, and then I have 36a plus 6b plus c is equal to 527. Okay, and then I have 100a plus 10b plus c is equal to 370. Okay. So we take 2 at a time and we eliminate the same variable. Okay. So I can take the first 2, and the goal is to eliminate a variable, right? So I can eliminate the A's, I can eliminate the B's, I can eliminate the C's. In this case, maybe it might be easier to eliminate the C's since they're all 1C. I just have to change one equation to negative, maybe. Yeah. So I can take my first 2 equations here, 36A plus 6B plus C is equal to 527. And then I'm going to multiply my first equation. It should be 2B, not B2. I'm going to multiply this equation by -1 to make this into a -C so that I can cancel out when I add them. So then what I get here is I'm going to rewrite my top equation because I want to keep things organized and nice. So now this will become -4A minus 2B minus C is equal to -424. So I multiplied everything in this equation by a -1. Okay. So now when I add these together, right, these will cancel, which is what I wanted. 36A minus 4A, that's going to be a 32A. 6B minus 2B, that's going to be a plus 4B. And then 527 minus 424 will give me 103. Okay. So I'm going to call this right here. I'm going to call it equation 1 because I didn't name the other ones. I'm using colors for those. So I now have my equation 1, which has A and B variables in it only. I got rid of the C's. Okay. So now I want to use another set of two equations from here and again get rid of the C so that I can get another equation with just A and B in it. Okay, and I can take any combination as long as it's not this same combination. So I can do these two right here. I can do equation, the pink and purple. I can do the blue and purple, right? So it depends on whatever you want to do at this point. So we can go ahead and we can do like the purple and pink. Okay. We can do the purple and the pink. So the purple here, we have 100A plus 10B plus C is equal to 370. And then my pink here, I have 36A plus 6B plus C is equal to 527. Again, right, one of these I'm going to need to change to a negative so I can get that -C in one of them. So I can go ahead and multiply. It doesn't matter which one really. I'm just doing this one because these numbers are smaller than that number. So we're gonna get $100A plus 10B plus C. And then down here we'll get -36A minus 6B minus C is equal to -527. Okay, so now when I actually do this, C's will cancel because I have a plus C and a minus C. 100A minus, or 100A, yeah, 100A minus 36A, sorry, I'm repeating myself, guys. 64A, 10B minus 6B minus 4B is equal to 370 minus 527. Okay, I hope you realize you're going to get a negative number here, -157. So this equation right here, this is now equation 2. Okay. So great, we have two equations with two variables. So we do another system of equations. We take equation 1 and we take equation 2. So we have 32A plus 4B is equal to 103. And we have 64A minus 4B is equal to -157. So now check this out. We automatically have two variables that are going to cancel. I have a positive 4b and I have a negative 4b, so I don't need to change anything. I just add straight through. So I have 32a plus 64a. That's going to give me 96a is equal to 103 minus 157. It's going to be a negative 54. Okay, divide by 96 because now I have literally one variable. And I'm going to get a is equal to, I believe that's 0.5, negative 0.5, is it not? No, it is not. It is negative 0.5625, or you can simplify that so that it's giving you a nice fraction instead of a decimal. Okay, so that does simplify to a nice negative 9 over 16. So that's your A. So then what do you do with this A? You take it back and you plug it into one of these guys to get B. Okay. We have over 16, so this either one of these would actually be great, but let's see, I just want to do the first one. So I take my A and I plug it in. 9 over 16 plus 4b is equal to 103. 32 over 1 here, that's going to cancel that. That'll be a 2. That's going to be negative 18 plus 4b is equal to 103, right? Yeah. Add the 18 over. You're going to get 121 divided by 4. You're going to get 30.25. Okay, or fraction wise, 30 and 1/4. But decimals are okay too. Okay, and then last but not least, you take both of these guys and you plug it in to one of these guys to get your C. I'm going to go with the smaller one because smaller numbers to work with, maybe? I don't know. For the second equation, how did we get negative 4b? Isn't it positive? Oh, shoot, you're right. Thank you for catching that. No, you did not make a mistake. I made a mistake. No wonder. I'm like, what's with all these funky numbers? But hey, it's the real world, so sometimes you get funky numbers. Okay, that is supposed to be a plus. Can we rewind? Rewind all the way back? Rewind to all of this? This is why you do math in pencil, guys. One tiny boo-boo. Thanks for catching that, Juan. That means all the rest of this, not all of it. Okay, all of our work is not wrong. Just that one bit that led us to other funky bits. Okay, so that means that before these can cross out, no one else caught that? Wow, it's okay. I didn't catch it either. Thank you for that, Juan. Yeah, I didn't catch that either. That means I got to multiply one of these by a negative number, right? So I can do either one of these by -1, which means 32a plus 4b is equal to 103. But then this becomes negative 64a minus 4b is equal to 157. Now we can cancel, not there. So this is going to be 260 now. And this will be a negative 32a. Yeah. So now I have 260 divided by negative 32, which gives me a is equal to negative 8.125. Thank you, Juan. Then we do the same process though. And then we take that and we plug it into one of these guys to get our b. So we can do the same one. 32 times negative 8.125 plus 4b is equal to 103. So this is going to be a negative 260 plus 4b is equal to 103. Add the 260 over. We get 4b is equal to 363, right? 260 plus 103. Yeah. And then divide by 4 on both sides. And you will get a 90.75. These still decimals, right? A 90.75. But that sounds a lot better. Okay. And then take these two guys and plug them into one of those. So again, we have, I'm going to do 4 times negative 8.125. I'm just using the first one. It doesn't matter which one you use, really. Plus 2 times 90.75 plus C is equal to 424. Okay. So 4 times negative 8.125. That is a negative 32.5 plus 2 times 90.75. That's 181.5 plus C is equal to 424. Add those two guys together, and you get 149 plus C is equal to 424. So 424 minus 149, we get C is equal to 275. Okay. So we have our 3 coefficients, right? The initial direction was find a quadratic model. So at the end of all of this, you're not done until you write the quadratic model with your 3 coefficients. So A is negative 8.125 x squared, okay, plus 90.75 x plus 275. And that's your quadratic model. All of that for that. Yay. Yay. We did it. Oh, that's right, what my nephew says every time he does something. He's like, I did it. So recap. Pick 2 equations. Eliminate a variable. Pick another pair of the equations. Eliminate the same variable. Take those 2 equations that you got from eliminating those variables. Watch your signs. Don't make my same mistake. Okay. Take those 2, put them together, eliminate another variable, solve for this remaining variable, take that, plug it into one of the ones with the 2 variables to get the other second variable, and then take those 2 and plug it into one of the original equations here to get the third variable, and then put them all in a quadratic function. Huh? All right. So you guys have work. Okay. I believe on. Wait, I don't know. Some of you might need that. Sorry. I believe. Let's see here. On our chapter 2 page. Um, 2.6. Where are you? Right here. You guys do have the applying quadratic functions, and then you also have the getting to know quadratics, homework 11. I'm gonna have you guys do your homework 11. Okay, so do your homework 11. It is the getting to know quadratics homework. Okay, so I want that due by next class period. So you guys are gonna work on this. We'll see. We'll you work on this in class together. Okay, applying quadratic functions there. All right. If you have any questions, please ask. I do have tutoring, guys, on Thursdays that you guys don't show up to, but I would really like for you guys to show up to, considering some of the grades in our class right now. So I want you guys to try to come to class, or come to tutoring, sorry, to get any help that you may need. Okay. But other than that, I will see you guys on Thursday. Have a wonderful, wonderful day, and stay safe.
MSK.
Bye. You too, Juan. Have a good rest of your day.